Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Today we are going to discuss about derivation of mirror formula for a convex mirror. Okay, so let us draw a convex mirror. So this is our convex mirror. This is our focus and this is center of curvature. Now let us assume an object is placed in front of the mirror. This is our object AB. This is our principal axis PA. Now let us take a point at the tip of the object from where light rays are coming out. So the first ray is parallel to the principal axis. So after getting reflected by the mirror, the ray goes in this direction, and if we produce the reflected ray backwards, it passes through the focus. And again let us take another ray which is directed towards the center of curvature. Okay, so after striking the mirror, the ray follows the same path but in backwards direction. So if we produce this ray backwards, if we produce the reflected ray backwards, it passes through the center of curvature. And let us take another ray which is important. Let us take another ray passing through another ray which is striking the pole. So after striking the pole, it gets reflected like this. So we know when a ray of light strikes the pole, then the angle between the principal axis and the incident ray is our angle of incidence, and the angle between the reflected ray and the principal axis is our reflected ray, sorry, angle of reflection. So now if we produce the reflected ray backwards, it passes through this point of intersection. So this point is the image of this point. So at this position we are getting a virtual image, which can be denoted by a dashed b dashed. Let us name this point D, and let us name this ray PQ. So now if we talk about the object distance, it is this distance which is measured from the pole. So the direction is opposite to the direction of incident light, so it is minus u. And if we talk about the image distance, again image distance is measured from the pole, but it is measured towards the incident light. That is why it should be taken positive. So plus v, and the focal length which is measured in the direction of incident light. Okay, this is plus f, and the radius of curvature which is again measured in the direction of incident light. So this is plus r. This is our direction of incident light. Okay, this is our direction of incident light. So the distances measured in the direction of incident light are taken positive, and the distances measured opposite to the direction of incident light are taken negative. So this is our diagram. Now let us try to prove it. Now look at triangle ABC. Triangle ABC, this bigger triangle ABC. So triangle ABC and triangle A dashed B dashed C. we can say angle ABC is equal to angle A dashed B dashed C. Okay, equal to 90 degree, and this is the common angle. Okay, this angle is common to both these triangles. Angle C is common. Therefore, we can say, so we can see in these two triangles, two set of angles are equal. So we can say that the third set of angles will also be equal. Therefore, these two triangles should be similar. Triangle ABC similar to triangle A dashed B dashed C. Therefore, we can say the ratio of corresponding sides will also be equal. So, AB by A dashed B dashed is equal to BC by B dashed C. So, BC is equal to, we can say, BP plus PC, and B dash C is equal to PC minus PB dashed. Okay, so BC B dashed C, this distance can be written as PC minus PB dashed. Now BP is equal to BP is equal to object distance, which is minus U. PC is equal to radius of curvature, which is plus R. Again PC is R minus PB dashed. PB dashed is image distance, that is V, plus V. So this is what we are getting. Now in triangle APB and triangle A dashed PB, PB dashed, we can say this is our APB and this is our A dashed PB dashed. We can say number one, we can say angle ABP is equal to A dashed B dashed P, equal to 90 degree, and angle APB angle APB is equal to angle BPQ is equal to angle A dashed PB dashed. Okay, why? Let us look at these two angles. Okay, APB and BPQ. From the laws of reflection, we know angle of incidence should be equal to angle of reflection. That is why these two angles are equal. And if we look at these two angles, BPQ and A dashed PB dashed, okay, this angle and this angle, BPQ and A dashed PB dashed, these two angles are vertically opposite angles. Vertically opposite angles are equal. So the first set of angles are equal because angle of incidence equal to angle of reflection. This is the reason. And this second and third angles are equal because they are vertically opposite angles. So we can say this angle is equal to this angle and this angle is equal to this angle. So we can say these two angles are equal. Okay. So we can say from this relation, therefore, or we can say angle APB is equal to A dashed PB dashed. Okay, so we can see two set of angles are equal for these two triangles. Therefore, we can say these two triangles are similar. Therefore, we can say triangle APB is similar to triangle A dashed PB dashed. So when two triangles are similar, we can say the ratio of corresponding sides will also be equal. So we can write AB by A dashed B dashed is equal to BP by BP by B dashed P. BP by B dashed P. So BP is our object distance, which is minus u, and B dashed P is our image distance, which is plus V. So now this is our relation 1, this is our relation 2. From these two equations or relations, we can equate the values of AB by A dashed B dashed. So we are equating the values of AB by A dashed B dashed. So this is what we are getting. Now by cross multiplying we get so dividing both sides of the equation by UVR, we get this 2 by R can be written as 1 by R by 2, which is equal to 1 by F. So this is what we are getting. Now friends, let us take some questions which are related to the mirror formula and linear magnifications. So this is our question where object distance is given, which is 15 centimeter. So U is given, which is 15 centimeter. For a convex mirror, and radius of curvature is 10 centimeter. But we know for a convex mirror the object distance is minus, that is negative. So u should be taken minus 15 centimeter. Now we can say that r is equal to 2f, which is equal to 10. So f is equal to 5 centimeter. So using mirror formula we can write in place of u we can write 1 by minus 15 plus 1 by v is equal to, for a convex mirror focal length is positive, or we can say 1 by v is equal to 1 by 5 plus 1 by 15, 4 by 15, or v is equal to 15 by 4, which is 3.75 centimeter. So this is our image distance. This is part 1 of the question. Now part 2. We need to find out the magnification. So linear magnification is equal to minus v by u. So minus v is 3.75 and u is minus 15. So minus and minus becomes plus. So 3.75 which can be written as 15 by 4 by 15, that means 1 by 15. So 1 by 4. So this is our magnification. That means size of the image is 1/4 of the size of the object. We know in case of a convex mirror the image formed is always the size of the image is always smaller than the object. So this is the part 2 of this question. Now solution of part 3. In case of a virtual mirror the image formed is virtual and erect. This is the part 3 of the question. Now let us come to another question. So the question says, when the object is placed at a distance of 40 centimeter from a concave mirror, the size of the image is one third that of the object. Calculate the image distance and the focal length. We know magnification can be written as so the linear magnification can be written as minus v by u. Now for a concave mirror, the value of u is always negative. So we can write u is minus 40. And the question says the size of the image is one third that of the object. So let size of the object be x centimeter and size of the image be x by 3 centimeter. This is our HO, height of the object, and this is our HI, height of the image. So this is our formula for magnification, which is also equal to m equal to minus v by u equal to, we can say, height of image by height of object. Now if we use this relation, we can say minus v, which is not known to us, by u, which is minus 40, is equal to height of image, which is a real image. So real image is always, for a concave mirror, the real image is formed below the principal axis. So when we measure a length below the principal axis, that length is taken negative. Okay, that length is taken negative. And when we measure a length above the principal axis, that length is taken positive. We know it. So height of the image, which is x by 3, should be taken negative because this length is measured below the principal axis. And height of the object, which is x, should be taken positive because this is measured above the principal axis. Now we can write minus minus can be cancelled, and x can be cancelled. So v is equal to minus 40 by 3. Here the negative sign represents that the image distance is measured opposite to the direction of incident light. That means the image is formed in front of the mirror. So this is the value of v, 40 by 3 centimeter. Which is equal to minus 13.33 centimeter approx. So the image distance is 13.33 centimeter, which is in front of the mirror. Now we need to find out f. So we can write 1 by f equal to 1 by u plus 1 by v. So 1 by minus 40 plus 1 by minus 13.33 let us write it like this: 1 by v, that means minus 3 by 40. So the focal length is minus 10 centimeter. So I hope the solution is clear to you. That's all for today. Thank you, friends. In our next physics class, we are going to solve more questions from mirror formula and linear magnification. And after that, we are going to start refraction.